Hello, my name is Danis and I'm staff front-end engineer on the AI framework team. In today's video of this easy AI experimentation series, we're going to talk about the basics of the basics, about AI terminology or AI glossary, whatever you prefer to call it. Generative AI, large language model, hallucinations, RAG. Apparently you've heard a lot of these things recently, but not necessarily realized what's that about. If that's the case, please stay tuned. Today we're going to talk about all of them. And the first thing we will start with is generative AI. What's that? Is it any AI? Not really. Generative AI is a technology within the AI umbrella term which is capable of creating new content. Text, images, music, even code snippets. Based on the underlying training data, generative AIs are capable of identifying different patterns and based on those patterns in the training data, generate new content which will seemingly follow the same patterns as they have been trained on. Examples of generative AI when it comes to, let's say, images are DALL-E and Midjourney. When it comes to text, ChatGPT and GitLab DuoChat. But what is within the generative AI which is capable of creating new content, which is trained on the data? It's the AI model. There are different types of AI models. There are unsupervised, there are supervised, semi-supervised, reinforcement models, generative models, and deep learning models. In particular, we are mostly interested in generative models because they are the ones capable of generating new content based on the training data, identifying those patterns. And that's the generative AI model, which brings us to the next term in our glossary, the large language model. So, large language model, or LLM for short. It is a mistake to think that any AI model is an LLM, large language model. The large language model is only responsible for generating new prose, support conversations in chat. It even can come up with new code snippets, but it's all about text. The main purpose of an LLM is to come up with the next word in a sequence based on the patterns it has been trained on, vast amount of data it has been trained on, but it generates only the text, hence the language part in the name of it. For example, a model generating an image is not an LLM. It's completely different. It's still generative model, but not large language model. Now that we've learned what the large language model is, let's talk about one particular problem with LLMs, which is hallucination. I'm pretty sure you've heard this term at some point, but what is that? Let's take a look at the example. So I am in the Vertex AI Google console, and let's try asking this model, which is Gemini 1 Pro, about one particular thing. I will copy the question here. So the question is, or the prompt is, what are the most recent issues with DuoChat are you aware of in the context of VS Code extension? Reply with issues numbers and links to those. Let's just ask and see what's going on. And the LLM, which is Gemini 1.0 in this particular case, comes up with a response. That's interesting. Okay, let's take a look. What's that? Recent issues with DuoChat VS Code extension. So first of all, it messes up. I didn't ask about DuoChat VS Code extension. It's VS Code extension with DuoChat in the context of GitLab. But this model doesn't really care about that. Feature request, add support for Duo video calls in the extension. Wow, that's fancy. I have never heard about this. It gives the number of the issue, doesn't provide the link. But there are some things like DuoChat VS Code extension GitHub repository. GitHub? Really? Let's take a look. I'm gonna copy this and I'm going to check this. And of course, there is no repository. So What happened here is, based on the vast amount of data that this LLM, in this particular case, Gemini 1.0 Pro, has been trained on, it tried to identify different patterns in the words and come up with some sensible text, which at glance resembles something meaningful, but it is nonsense. This information doesn't exist. So the LLM invented this information based on different patterns it has been trained on, assuming that maybe that's the case. But it doesn't know anything about what I was asking for about. And that's what we call hallucination, when LLM comes up with not existing information. Before we talk about another quite common type of models in the world of AI, we have to talk about one particular important term: vectors. Vectors and vector storage are things that you will hear a lot in the world of AI. And in order to better understand what the vectors are, let's consider a box of crayons. Imagine you're looking at the box of crayons from the top, you see all the colors, and as a human being, you know that in order to pick orange crayon, you have to reach out for this one. In order to take the yellow one, you would reach out to this one. But that's because we have the sight. Machines, on the other hand, they don't have this sight, so they have to have some instructions on where exactly the orange color or yellow color are located. In order to tell the machine to reach out to orange color, we would tell it to go to the first row, third column, and pick the crayon from that spot. And this information, first row, third column, 1, 3, 1, 3, is exactly the vector. Vector is a numerical representation of some information, telling the machine where exactly to reach out to retrieve that information. If we would need to code yellow color, it would be first row, first column, 1, 1. These are vectors. Vectors represent some useful information like placement of yellow crayon or orange crayon in numerical format. And the place where all of those vectors are stored, or box in our case, is the vector storage. Vector storage allows you to store the vectors in the organized form so that machines or models would know where to reach for the information. Vectors and vector storage. And let's talk about another type of model where this term is used a lot. Embeddings model. Before we talk about the embeddings model, yet another very popular type of models talked about in the world of AI, let's talk about what the embeddings are in general. And for that, let's get back to our box of crayons. So we talked about vectors, where we store information about every particular crayon, about every particular color being located on a particular spot in this box. But now imagine that in addition to that information, you would also have another additional layer of information, the transparent one, on top of this box, which will tell you, for example, that this yellow color is similar to this one. At least it is more similar than this yellow color similar to this black color. It also might contain information that, for example, if you mix this yellow color and this blue color, you will get this green color. So information about similarities, about what you can do with different types of vectors, what you can mix, what you can combine, what matches each other. These are all things that the embeddings provide. So embeddings is this additional layer of information on top of your vector storage. And then embeddings model is exactly the model which creates this type of embeddings or retrieves this type of embedding depending on your task. When we create this embedding, it is very important to know that creation of the embeddings and retrieval of the embeddings should be done with exactly the same model, so that model would understand those embeddings that were stored. We talked about embeddings, about the colors, how embedding model can work with colors. By the way, how does embedding model know that this color matches with that color, for example? This is again just based on training information. You can feed your embedding model, you can train your embedding model on information about color theory, about different well-established color patterns. You can even teach it on the information about crayons and get this additional information. But do not think that embedding model is about colors or about images. It is about anything. It can create information about text, about any underlying vector information. For example, in the context of GitLab, embedding model can tell you whether this issue with title and description is similar to this issue with title and description. Or, for example, changes in this merge request are similar to changes in this merge request. So embeddings model allows you to find similarities and relationship. Large language model, remember we talked about this, large language model is about creating the next word in the sequence. It's about following the things. It's about directly providing the content, generating the content. Embeddings, on the other hand, provide you with the relationship. It's about relationship between different parts stored in your vector storage. Now let's talk about AI tools and AI agents. Tool and agent, you will hear these terms a lot, and they come together most of the time. So what are these? In order to better understand what they are, let's talk about autonomous vehicles. So vehicles capable of driving on their own. In order to drive, a vehicle needs to gather a lot of information about the surrounding environment. It needs to read the road signs, it needs to read the lines on the road, it needs to detect the pedestrians, a lot of things like this. So, AI tool is one of these functions. Let's say reading the road signs is one tool. It is dedicated to reading the road signs. It is trained on road signs. It is trained on interpreting those road signs. Then another tool is dedicated to reading the lines on the road. So it is trained to distinguish between solid lines and dashed lines. And then another tool is dedicated to detecting the pedestrians. It is trained on humans, on animals, to be able to detect what it is seeing in front of them. So all of these are separate tools. They can be implemented with different types of generative AI. They can produce different results, but then these results come into one place. In the world of AI, it is, let's put it, a prompt. The prompt which gathers information from all of these tools, and then reacts on that information. So this autonomous vehicle is an AI agent. It is capable of running on its own without human interaction, using different tools which supply additional information to this bigger AI agent. So AI agent, sometimes AI agent can even contain only one tool if it's a simple implementation. But more often than not, an AI agent contains of several tools dedicated to different tasks. For example, in GitLab Duo Chat, we have several tools dedicated to fetching issue information, tools dedicated to some other tasks, and then all of them get together in this AI agent, which interprets that information and produces the result to the user. And now we're getting to the pinnacle of all these unknown words and terms. RAG, Retrieval Augmented Generation. What is this about and why would we care? You will be surprised to know that even during today's video, we talked about RAG without naming it a couple of times. Retrieval augmented generation. It is about retrieving information, augmenting prompt, generating response to the user. Why do we need this technology? It is model-based technology which helps to overcome the limitations of large language model. What are those limitations? There are a couple of those. First, large language model is trained on the data, on the fixed set of data up until certain point. And it's also in a lot of cases trained on the publicly available data. If you want your LLM help you solve some problem local to your project, which is private, LLM doesn't have information about it. So you have to somehow retrieve that additional information and put it into the language model. Another thing, another issue that RAG tries to solve when it comes to LLMs is the contextual window. What is contextual window? Every LLM has some sort of a buffer or contextual window where you can put additional context in order to allow LLM to focus on your particular problem. Again, LLMs are trained on vast amount of data, and it can hallucinate really, really easily, as we have seen previously. In order to narrow the scope of LLM's interest, we have to provide it with the context. But that context window where you can put the information is pretty limited for a lot of LLMs. So what you have to do, what RAG allows you to do, is it allows you to get to your information specific to your prompt, to your request, to your project, to your company. Get that information, alter it, probably funnel it in order to get the absolute essence of the context required for LLM to come up with the response. Then RAG augments the prompt in order to supply that additional context and generate the response to the user. Using your context, you get the response not from the generic data the LLM has been trained on, but based on the data that you have supplied from your project. This is what RAG is about using your data to generate the response. As simple as that, technically. During today's video, we talked about a lot of different things in our AI glossary. We talked about generative AI, large language model, hallucinations, vectors, embeddings, RAG. Now, I hope that it will make a lot of things for you easier to understand, and you will be more familiar when you hear anybody talking about AI. Now, please, go try and play with these fun technologies. Go and see LLM hallucinating. It might produce a lot of fun results. Go and try experimenting with a tool. Try experimenting with several tools and combine them into the agent. And then all of a sudden, maybe you will end up building a RAG. Have a great one.